Okay, hi guys, how are we going? So I'm going to create some videos to aid in your studies. This will be something that you can watch and rewatch at your leisure. I'll be putting up PowerPoints online, and either you can watch the video along with the PowerPoint, take notes, or you can just watch the video. But this is a good resource for you to use in your studies before the test. So the second part of the nervous system that we're going to be exploring today is the brain. So the brain, compared with other animals, humans have very, very large brains for their body size. So here we've got a table, a diagram, a graph that shows the body weight of animals. So as we go along here, we got higher and higher body weights. So we got the sperm whale and the blue whale, who obviously are the heaviest animals on the planet, and the shrew, and the bat and the mouse, they're the lightest. And then we've got that compared to the brain size. So as we go up, we're getting higher and higher brain sizes, bigger and bigger brains. So we've got man here, which is got quite a big brain size for how big it is. So we've got pretty much the smartest animals on the planet up here. We've got horse, chimpanzee, dolphins. They all rate very, very intelligent. And of course, man's brain size is very, very large compared to our body size. So the way scientists and neurosurgeons and neuroscientists look into the brain is through using something called MRI. So MRI scans are called magnetic resonance imaging scans. So these use strong magnetic fields to look inside the living brain. It's useful for diagnosing brain tumors and finding areas where the brain might not be functioning completely as expected. Another function of the brain is that they've just discovered recently in the last few decades that the brain is actually plastic. And by plastic, I mean like the Play-Doh that we're going to be using later in the lesson. It can be molded and shaped in terms of if one part is not functioning correctly, then another part of the brain can actually take over and perform the functions of that part of the brain. So there are situations where this can happen, but for the most part, if there is brain damage, it's quite often permanent brain damage. That's why the brain has to be protected by the skull, and that's why you should be very, very careful about brain injuries and injuries to the head. Okay, so the next slide, we went into watching a video, so I'm just going to pass on to the next slide. So a stroke is an example of something that's quite common in our society. It's usually through people's eating habits, and if they're smokers or drinkers, it increases your chance of stroke. What happens is that the brain actually gets a blockage in one or two of the arteries that are in the brain. So the brain contains a lot of very small arteries, and a rupture or a blockage stops the oxygen supply to the brain, and therefore that part of the brain becomes damaged. So let's get into the different parts of the brain. We've got the cerebrum. So when you're thinking of what the human brain looks like, you're most likely thinking of the cerebrum. So the cerebrum is the huge thinking part of the brain. It's where all our thoughts come from. It's where all our processing comes from. When you're thinking through watching this presentation right now, your cerebrum is the part that's active. It occupies 80% of the brain. It consists of a whole bunch of different lobes. Its folded surface gives a huge amount of surface area, therefore there's more neurons that can interact. You can pack in more neurons into the brain. It increases the surface area and therefore the capability of the brain by 3 times than if it was a smooth surface. It is the cerebrum that the higher intellectual functions of the human's mind takes place. So everything we do with thinking, seeing, processing information is done through the cerebrum. So a closer look at the cerebrum. It controls your conscious thoughts and voluntary movements in every part of your body. You scratch your nose, it's the cerebrum controlling your movement. It also receives sensory information from all parts of the body, and it makes the decision on what you do based on that stimuli. So heat, light, and sound are all processed in the cerebrum, and we'll go into the two different hemispheres and what their functions are in thinking. So you can see there's different parts of the brain that light up, all the neurons that light up and activate based on what the stimulus comes in or what you're doing. So touching something, that part of your brain lights up. Movement, this part of your brain lights up. If you're looking at something, that part of the brain lights up. So right now, if you're writing notes, this part's lighting up, this part's lighting up, this part's lighting up. If you're thinking through this and actually processing it, then this part is lighting up as well. And of course, the hearing part is lighting up. So there's multiple different parts of your brain that perform different functions. So the left and right brain function differently. They perform different things. Even though the two hemispheres are joined together, they actually perform different things. So language, science and maths, logical thought, processing information, they all happen in the left brain. The right brain is focused on creativity, art and music, intuition, kind of like the spiritual side of the brain, the soul of the brain, whereas this is the analytical, the mathematical. So have a think about what kind of, what hemisphere you primarily live in. You may be both, a bit of both. Some people are very creative and very artistic. Some people are very analytical and scientific thinking, and they love languages and very good at languages. So have a think about what kind of hemisphere you primarily live in. So neuroscientists know all this about the brain by studying fMRIs. So this is a brain scanning imaging process, and they scan the brain whilst a person is doing something. So they've scanned the brain whilst a person is listening to words, and these parts light up. They scanned it while they're reading something, and these parts light up. And it shows them through all these actions and which parts light up in the imaging process, what part of the brain is associated with which action. So the cerebellum is at the base of the brain. It is around the upper neck where the skull curves inwards, and it's responsible for coordination and balance. And without it, you wouldn't be able to walk. You wouldn't be able to coordinate your movements. This is the very basic functions of your brain, and very, very essential. So if you have damage in that part of your brain, it's very, very difficult to walk and coordinate yourself. So the medulla and spinal cord, these parts here. So the medulla, don't worry about this word oblongata. The medulla here, the spinal cord is here. The lower parts of the brainstem are seen where the spinal cord widens just after it passes into the skull. So it controls the body's vital functions such as breathing, blood pressure, and heart rate. Damage to this area can be fatal. So we're seeing the brain going from this higher thinking, analytical thinking, processing information, going down to lower levels, controlling your body, going down to lower levels, which is just blood pressure, breathing, and heart rate. So it's becoming less and less in your control as we go further down. Now, of course, the brain and the spinal cord are so important to how you function, how you and your way of life. I mean, everything comes down to the way you think and the way your brain controls your body, that it needs to be protected. So the brain and the spinal cord are so essential that they've evolved special protective structures that surround them. A covering of bone known as the cranium, so it's not the skull, we don't call it the skull, we call it the cranium, protects the brain. The vertebrae is the bony structure that protects the spinal cord. So the vertebrae, just highlight that. maybe not. Both the brain and the spinal cord are surrounded by fluid called the cerebrospinal fluid, and this provides nutrients to the neurons and acts as a shock absorber. So, cerebrospinal fluid covers the inside of the cranium, inside of the top of the skull, and it also covers the spinal cord underneath the vertebrae. Now, getting to how the brain actually works and what it boils down to. You could say all of our thoughts, all of our actions and emotions can be boiled down to three principal functions. You've got sensory input, you've got response, and you've got motor input. So sensory input could be an example, something that's coming in. Sensory, something you're sensing. So something coming in like you're seeing with your eyes or you're touching something with your hands. That input serves nerve impulses down your hands, down your arms, or through your eyes, or through whatever is exposed to that stimulus, and it's going either into the brain or the spinal cord. And at that point, in the central nervous system, remember the central nervous system is the brain and the spinal cord, there is a response. So the brain and the spinal cord are the control center. And then there is a motor output. So by motor, think of a motor of an engine, it's moving. Motor as in the output is causing movement to respond to the sensory input. The motor output is responding to the sensory input. So the motor outputs could be you stopping moving because you see a car approaching, or you pulling your hand away because the knife you touched is very sharp. So it's a three-part process that everything that comes into your brain and then responds to and comes out, whatever movement or action comes out, is what pretty much all your actions are. So, response to stimuli. Organisms can respond to stimulus, a physical or chemical change in the environment around you. So, organisms must be able to respond and react to changes in the environment to stay alive. An example here is the picture of an owl's eye. When it gets dark, the pupils dilate. When they dilate, there's more light coming in, and that's a response. The owl's eye's response to the external environment. The external environment, the darkness being the stimulus, and it's a natural reaction. Okay, so that's the end of this video. Hopefully this helps some of you. Please, if you want to watch and rewatch this, I advise you to take notes. And this would be one of the best forms of study, because what I'm doing here is going through stuff that specifically you need to know for this course. Okay, thank you, and I hope you enjoyed this. See ya.